GPT has a superpower. It decodes our messy thoughts and spits out exactly what we didn't know we wanted. But exactly how it does so is the $3 trillion question. I see you, NVIDIA. Imagine words don't exist, but 2D shapes do. A point can be represented as pairs of numbers, x and y. Many together form an image. With another axis, we can also form 3D shapes, describing space numerically. We could code a program to make plots look like previous ones, but this does not show understanding, and x, y, and z don't really mean anything. Consider one axis called car and another one train. We can look at a document, count the number of times each word occurs, and represent this as a coordinate. Doing so for a series of them, similar documents will be closer to each other in this vehicle space. Adding more axes represents more words from the source, which stores more detail. This now describes text numerically. But imagine GPT here shifting through countless points in this multidimensional space, trying to pinpoint the precise location that matches a user's input. Whilst this might work for retrieving existing information, albeit very slowly, it fails to account for its ability to create new, contextually relevant responses. We need some way to now describe meaning numerically. Following the previous example, let one axis be car-ness and the other train-ness. The postfix ness here is used to describe some words' likeness. This will become more clear. For example, car and train must be very high on their respective axes, and bus, plane, and cycle as follows. Can you see why? As we add more and more axes, the n different directions all embed unique meanings. Using large amounts of training data, the location of different words relative to others is used to tweak their positions. All this data forms the knowledge base. Imagine if we could see more dimensions, and embedding could represent queen subtract woman as king, preserving semantic relationships. This embedding matrix is an n by n array which stores the position of all the words embedded, 30,000 in the English language. The output is then generated by repeatedly multiplying ME with the last word. This is close to the most likely next word's embedding, which can be retrieved, producing the final text. But the real question is, can we represent emotions numerically? Would that be enough? And where is this all going to take us in the future?